good morning, good afternoon, good evening. Wherever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have been discussing about the principle of calorimetry, and we have certainly ended the class due to some technical problems. So today we will be continuing the class after that. So today what we are going to mainly discuss is about the latent heat and specific latent heat. You have already known about the specific heat capacity, isn't it? And you have also learnt about the definition of specific heat capacity, I think, and the concepts are clear. So from that class we will be continuing and we will be discussing about the latent heat, specific latent heat. Okay, so what is latent heat? Now see, before discussing latent heat or specific latent heat, let me just briefly discuss with you what are the various changes in phase that takes place. Okay, you know that there are three phases of matter, mainly three phases of matter that you see practically around you. There are two other phases also, but we are not going to details. Just we are discussing only those phases which you see around yourself commonly. Okay, so there are three phases: solid, liquid, and gas. So there is a conversion chart. I can just briefly recapitulate that. So let us consider solid. Okay, now let us consider here liquid, and let us consider here gas. So these are the three states of matter. I think all of you know about these three states of matter: solid, liquid, and gas, isn't it? Yes. Okay, so what are the name of the processes of conversion between these states? See, when you heat a solid, the solid starts slowly getting converted into this liquid phase. This conversion from solid to liquid is called melting. What it is called? Melting. Or sometimes it is also referred to as fusion. You must have heard about the fusion of ice, isn't it? Melting of ice or fusion of ice. So the process fusion. Okay. Now, when you cool the liquid, just the opposite process. When you cool the liquid and the liquid slowly gets converted into the solid, this process is called, freezing, isn't it? So this process is called freezing. Okay, so it's freezing. Fine. Now, when you heat a liquid and slowly the liquid starts getting converted into the gaseous form, that conversion is called, what it is called? It is called vaporization or boiling. What it is called? Vaporization, or it is also referred to as boiling. Now be careful here, vaporization and evaporation are not the two same things. Vaporization and evaporation are two different things. I will be giving you a just brief explanation. So just watch the video, you will be clear about the differences. And when you cool down a gas, it gets converted into a liquid, and that process is called condensation. Isn't it? Condensation. Okay. Now, what happens if you directly there are certain solids which when unheated directly gets converted into gaseous form without getting converted into the liquid form. So that kind of like camphor, naphthalene. Okay, so these are some of the substances that directly gets converted into gaseous state from the solid state. That conversion is called, what it is called? It is called sublimation. Okay, and the reverse process, that is directly conversion of a gaseous phase into the solid phase, is called deposition. Okay, so these are the various conversions. So I think this chart is clear to all of you. Okay, fine. Now see what is common in all these processes. Can you just explain what is common in all these processes? Actually, all these processes takes place at a fixed temperature. It may be freezing, melting, boiling, condensation, sublimation, or deposition. All these processes takes place at a constant temperature. So what is the similarity between in all these processes? That temperature remains constant during these processes. Temperature remains constant during these processes. Okay, so during these processes what happens, you supply heat or you remove heat, but the temperature does not change. It sounds a little bit odd, but this is actually the main phenomenon that is occurring here. The temperature remains constant. So where does the heat that you supply goes, or what happens to the heat that you withdraw? So when you withdraw the heat, that is take out the heat or supply the heat, what happens is actually the potential energy of the molecules is increased. I repeat again, the potential energy of the molecules is increased. You must have read this in your lower classes, okay? And in the previous lecture that we have been discussing, that when you heat a solid but it heat a substance but its phase is not changing, what happens? You heat a substance but its phase is not changing, what happens there? In that case, remember, in that case, actually what happens in that case, the kinetic energy of the molecules either increases or decreases. When you give heat to a substance, the kinetic energy increases. When you remove heat from the substance, the kinetic energy decreases, isn't it? Okay. So like that, the potential during all these processes, what happens is that the kinetic energy does not increase or decrease, rather the potential energy of the molecules decreases or increases. So I must just not write it down here. So first thing is that temperature remains constant, and the potential energy of the molecules increases or decreases depending on whether you are supplying heat or you are removing heat. Okay, depending on that, the potential energy increases or decreases. Okay, fine. So this is the process. So I think the concept is clear. What happens here? Actually the temperature remains constant, potential energy increases or decreases. Okay, fine. Now what happens? So the heat that you give or remove during these processes is not actually seen in form of temperature rise or fall. So actually it is not measurable. The heat that you are supplying or that you are removing is not measurable. When there is no phase change in the substance, what actually happens, that you can actually observe that heat is being given or removed by seeing the change in temperature. But in these processes there is no change in temperature. So actually the heat that you are supplying or removing, you cannot actually observe it in any measurable form. Okay, so the heat can be removed or supplied, but there will be no change in temperature. So this kind of heat that you supply to a substance or remove from a substance during its phase change, the phase change may be from solid to liquid or the reverse, liquid to gas or the reverse, or gas to solid or the reverse. So during all these phases, the heat that you supply, the heat that you give is called, I think the term, maybe you know the term is latent heat. The term is latent heat. What is the term? So this is the latent heat. Latent heat. Okay. So, and when you record this latent heat for unit mass, it is actually called specific latent heat. What it is called? It is called specific latent heat. When the mass of the substance is unit, is 1, in that case it is called specific latent heat. Okay, so I think it is clear, specific latent heat. Okay, so this is the main theorem regarding the change of phase. Okay, so specific latent heat, so when it is denoted by the letter L, and it can be written in the form, how can you express it? It is written in the form Q is equal to M into L. This L is the specific latent heat. Okay, specific latent heat. Okay, specific latent heat. Fine. Specific latent heat. It is the specific latent heat. Okay, so specific latent heat is basically the amount of heat that you are supplying, when to a unit mass of substance when there is a change in phase. And why this